Here I'm going to be looking at how to balance equations using oxidation numbers. Okay, so we're continuing redox, but this time balancing equations. This is a past paper question that came up in 2014. The first part of the question says define oxidation in terms of electron transfer. Well, if we just remember our mnemonic oil rig, oxidation is loss and reduction is gain, so oxidation is the loss of electrons. In terms of change in oxidation number, oxidation is an increase in oxidation number on going from one species to another. All you need to say there is it's an increase in oxidation number. Okay, so next we're asked to identify the oxidizing agent and the reducing agent, okay, using oxidation number. What I would do here is I would just write out the equation in my workbook as they've given it to me, and I'd assign oxidation numbers. So we'll start with the first species. Well, this is an element in its standard state, so that's going to be 0. Then I'm going to go across to the other cadmium species. That's a cadmium 2+ ion, so therefore the oxidation number of that is +2. Well, we can see straight away what's happened to cadmium. It's gone from 0 to +2, so that's an increase in oxidation number, so we know that that must have been oxidized. Next we look at the hydrogen ion. Just going to change colour for that. Hydrogen ion is the 1+ ion, so the oxidation number there is +1. Then we continue to go across. Nitrogen, in this case here, we've got the nitrate ion has a total charge of -1. There are 3 oxygens, so that's going to be -2 times 3. Well, the total. So we're going to go across the next nitrogen species, nitrogen monoxide. Well, the oxidation number of oxygen here is -2, so this must be +2. I can see already that the nitrogen has gone from +5 down to +2, so that must be reduction. Cadmium has been oxidized up to cadmium 2+, so if that's been oxidized, then something must have oxidized that. That something is called the oxidizing agent, and in this case the oxidizing agent here is our nitrate, NO3-. In particular it's the nitrogen in the nitrate, but for answering the question you can just say that the oxidizing agent is the nitrate. I want to see what's the reducing agent. Well, the reducing agent is the chemical reagent that causes something to be reduced. Well, the nitrate has been reduced from +5 to +2, particularly the nitrogen in the nitrate. So the thing that caused that to be reduced must have itself got oxidized. That is the cadmium. Just written there, the reducing agent is the cadmium. The reducing agent always gets oxidized, and the oxidizing agent always gets reduced. The reason being is the oxidizing agent causes something else to be oxidized, and the reducing agent causes something else to be reduced. Now we're going to balance the equation. There's a few rules for balancing equations. First of all, we look at the individual species that's been oxidized and reduced, and we write out their half equations. Half equations are equations which show, in terms of electrons, what's happening to each individual species. So we're going to start with cadmium. Oxidation, as I said at the start of the question, is a loss of electrons. So the cadmium has been oxidized, so it has lost electrons. So we could say that cadmium is -2 electrons to form Cd2+, but by convention we always write electrons in terms of a positive sense, so we write plus electrons. So instead of writing -2 electrons here, we're going to write +2e over the other side. So the half equation for the cadmium is Cd goes to Cd2+ plus 2 electrons. The next thing we look at is what's happening to the nitrate, and here's where some of our rules come in. So I've written out the rules there for the half equations, particularly for this next part. So we're going to start off with the fact that we've got a nitrate ion, NO3-, going to nitrogen monoxide. And we're going to look at what's happened to the nitrogen. It's going from a +5 oxidation step to a +2, so we said that's a reduction. Well, in terms of electron transfer, reduction is a gain of electrons, so therefore the nitrate ion must be gaining 3 electrons, because we've gone from +5 to +2, which is 3. So that has gained 3 electrons, because reduction is gain. The next thing we follow here is we balance the electrons. Now we're balancing the oxygens with water. So there is 3 oxygen atoms on the left, and there is 1 on the right. So there's an excess of 2 on the left, so I need to balance that with 2 water molecules here. Again, the reason for that is whenever you have an excess of oxygen atoms, you balance that with water molecules on the other side of the equation. Right, now I'm at the fact that I've got 4 hydrogens on the right. I just need to add 4 H pluses, which is this step here, to balance those water molecules. So in this next step, I'm going to go back to this stage now, and I've written out my half equations for the cadmium and for the nitrate. I'm now going to balance the electrons in each half equation, and this is a little bit like in maths simultaneous equations, when you're trying to make the number of electrons on either the side of the equation the same. So because I've got 3 electrons here and 2 here, I'm going to multiply this by 2, and I'm going to multiply this whole line by 3. That should give me 6 electrons on the top, on the right hand side here, and it should give me 6 electrons here, and they will balance each other out. Because there'll be 6 on the left and 6 on the right when I add them together, I don't need to include them in the overall equation. In fact, we don't include electrons in the overall equation. So I'm going to move that down now. Multiply the top line by 3, that's 3 cadmium goes to 3 cadmium ions plus 6 electrons, and I've multiplied the nitrate side by 2 here. And then I've just added the 2 lines together. 3 CD plus 2 nitrates, NO3 minus, plus 8 H plus, goes to 3 CD2 plus 2 NO plus 4 H2O. And that's the balanced equation done, with a reminder of the rules on how to do it there. Okay, so that's the 2014 redox balancing equation. I'm just going to go through another example now. Common one is the dichromate ion and the iron 2 plus ion reacting. So I'm going to start off by writing the half equation for the dichromate ion. So there are 2 chromiums on the left, so I'm just going to multiply that by 2. The oxidation state of the chromium, or oxidation number of the chromium in this particular species is plus 6, because I've got an overall charge of 2 minus. I've got minus 14 coming from my oxygens, therefore I need plus 12 to get back to a minus 2 oxidation state overall. So the chromium here, each of them must be plus 6. This chromium here is plus 3 because it's a charge on the ion, so therefore I've gone from plus 6 to plus 3. It's gone down in oxidation number, that's reduction. What I'm going to have to add in here is the fact that that's gone down by 3 electrons, but it's happened twice, so it's reduction, so this has gained 6 electrons. Now that I've done the electrons for that, we're just going to look at the waters. There is 7 oxygens on the left here, so therefore there must be 7 water molecules, 7 H2O here to balance that, and therefore the next thing I'm going to do is balance the hydrogens with H+. If there's 7 by 2 hydrogens here, there's going to be 14 H+. There. So that's that balanced. The next one is the iron 2 plus. Iron 2 plus going to iron 3 plus 1 electron. Reason being, it's increased in oxidation number from 2 to 3, so therefore it's been oxidized. Oxidation is the loss of electrons, so the iron 2 plus loses electrons, and by convention then we write it as plus 1 electron on the right hand side rather than minus 1 electron on the left hand side. Then to balance this, we've got 6 electrons here, 1 electron here, so we need to multiply that by 6 when we are following this rule here, rule number 3. We multiply that by 6 and then add them together. And that is what we get, which is the balanced redox equation. So there are the rules on the right. And there's plenty of past paper questions for you to practice using the same methodology to follow the rules here, and you should be able to do them.